Alright, welcome back, and we're doing paper 2, January 2022 for chemistry. Alright, so the first question, we're doing all questions tonight, by the way. So let's get started. So, a student conducted an experiment to investigate the reaction between calcium carbonate and dilute nitric acid. He weighed 1.8 grams of powdered calcium carbonate and allowed it to react with excess dilute nitric acid. The volume of gas produced at 10-second intervals was measured for a total of 80 seconds. Table 1 is a record of the volume of gas produced from the reaction with the powdered calcium carbonate. Figure 1 is an incomplete diagram of the arrangement of the apparatus used in the experiment. So the first question says, complete figure 1 by drawing and labeling the remaining apparatus to show how the gas was collected and measured during the experiment. So I have here a gas syringe with a plunger that is going to move as the amount of gas given off increases, and that'll be the CO2, the carbon dioxide, and then I have a rubber band right there. So that's pretty much how it should look. Then it says, using the axis on figure 2, plot a graph on page 5 showing the volume of gas produced versus time for the reaction of dilute nitric acid with the powdered calcium carbonate. Label this graph A. Alright, so I'm going to plot this graph. So I'll be going back and forth just like how you'll be going back and forth on the exam. Okay, so here's the graph. The first point is the first point we have to plot is 0. When time is 0, the volume of gas collected will be 0. That's the first point. It looks like it's plotted for you already. And now the second point is that when the time is 10 seconds, the amount of gas produced is 100. So the easy part is the time axis, which is on the x, because everything is going up in increments of 10, 20, 30, 40, 50. So we don't have to worry about this because we know it's going up equally. So all we have to look at is the y-axis. We have 100. So the first point is 100. So yeah. Here we go. When it's time 10, and we have, and what's so nice is that they label the axis for us. So at 10, we go straight up to 100, and we put our point there, and make sure you circle your point. Look at how they did their point. That's how they want you to make your point. So 10 is 100, and I think 20 was 190. So how are we going to find out what's 190 between here? Simple. Between here, you just say, well, or 200, you always subtract the smaller number from the larger number, and then in between here is 10 small spaces. You want to know how much each space is in between here, the smaller spaces, so we're going to divide by 10. And so 200 minus 150 is 50 over 10, which gives us 5. So each space is 5. So this is 155, this is 160, 165, 170, 175, 180, 185, 190. So 190 is 2 spaces below 200. So let's go here. 2 spaces below 200. And we're good. So each space is 5. Okay, so don't forget that. Alright, so let's go back here. Let's see. When it's 30, it's 250, and when it's 40, it's 280. So let's go here. When it's 30, it's 250. So that's easy. 30, 250, and 40 is what? I forgot. 40 is 280. 40 is 280. So we have here 260, 270, 280. So this is 280 right here. And then now let's look. Oh, 280. 550 is 320. Then we have 340. So we're going here 320. So this is 10, then 20 here, and then we have 340, 20, 30, 40, and then everything else is 360. Cool. So at 70 we have 360, and at 80 we have the same 360. Voila! So that should be how you plot your graph. You don't have to worry about putting a title, and everything seems fine. So the only thing you have to do is draw a line, well, a curve, best fit curve, and I'm going to attempt this using my online pen. So I'm going to use this right now and try it. Of course, I have my answers on the next sheet, but I'm going to show you. So you write the best fit curve. Of course, mine might not be the best, but I'm trying. And then this goes straight across like that. Yay! And then they said, this is what they said. They said, using the axis on figure 2, plot a graph on page 5 showing the volume of gas produced versus time for the reaction of dilute nitric acid with powdered calcium carbonate. Label this graph A. So don't forget to label it A. So this graph is labeled graph A. Yay. Okay, so that's the answer right there. Okay, so this is the answer that I have. Nice, looks just like what I plotted. And then it says write a balanced equation including state symbols for the reaction between calcium carbonate and dilute nitric acid. So you need to know this. So we know calcium carbonate looks like this, CaCO3, and they already told us that it was powdered, so it's a powdered solid, plus dilute nitric acid, which is HNO3, and acids are always aqueous. Then we have now, whenever you have a carbonate reacting with an acid, you're going to always have carbon dioxide being given off, which will be the gas, and then you're going to have some water, and of course you're going to have the salt, which is calcium nitrate. Okay, yay. If you look here, you would see that the nitrate anion, there are 2 of them, and there are 2 hydrogens on this side. Okay, so what I would do is show you how to do it. So you could balance this off by saying, well, I have a calcium over here, I have a carbon atom. The nitrate anion didn't break apart, so that we don't have to deal with in terms of breaking it apart. We have to break apart the carbonate anion because it broke apart into carbon dioxide and water. So we have to look at this O, and then we have H, and then we have NO here, NO3. So the same atoms are on the right, so we write them here. So this is how you balance. So we have 1 carbon over here, 1 calcium over here, 1 carbon atom, 3 oxygens. We have 1 hydrogen and 1 NO3. Meanwhile, over here we have 1 calcium, we have 1 carbon, we have, in this sense, 3 oxygens, then we have 2 hydrogens and 2 NO3 nitrate anions. So we put 2 here. So what doesn't look the same is the hydrogen and the nitrate anion. So it looks like we put a 2 here. So now we're going to have 2 and 2. Everything balanced. Yep, 1 1 3 2 2. Yep. So we can now get rid of our little helper set here. Okay, great. Now it says says calculate the volume of gas that can be obtained from reacting calculate the volume of gas that can be obtained from reacting 1 gram of calcium carbonate with dilute nitric acid at RTP. So theoretically, we see here that so calculate the volume of gas that can be obtained from reacting 1.8 grams of calcium carbonate. So from here we see the relationship between calcium carbonate and carbon dioxide is a 1-to-1 relationship, right? So granted it's a 1-to-1 relationship, we want to figure out, well, if you have 1.8 grams of calcium carbonate, you should get the same amount of moles from the calcium carbonate. So we say, we know 1 mole, let's write in our space here, calcium carbonate, right? 1 mole of calcium carbonate is equal to 100 grams. Why? Because calcium has a mass of 40, carbon a mass of 12, and then oxygen is 3 of them, so we're going to say 3 times 16, and what we get 40 plus 12 plus 16 times 3, which is 48. When you add these 3 numbers up, you definitely get 100. So 100. So we see that if 1 mole of calcium carbonate has a mass of 100 grams, then X mole of calcium carbonate would have a mass of 1.8 grams. Now writing this how we understand, we say 1 over X is equal to 100 grams over 1.8 grams. And we just solve for X, so we say 1 times 1.8 grams divided by 100 grams is equal to X. X would therefore be equal to 0.018. So 0.018 moles. There are 0.018 moles of calcium carbonate in 1.8 grams of calcium carbonate. So therefore, if you have 0.018 moles of calcium carbonate, then 0.018 moles of carbon dioxide should theoretically be produced from that amount, right? So now that we have our moles, all we have to do is equate them. It says 1 mole of any gas would occupy 24,000 centimeters cube of space, right? So therefore, if 1 mole of carbon dioxide, if 1 mole of carbon dioxide occupies 24,000 centimeter cube of space at RTP, then 0.018 mole of CO2 would occupy X space. So again, you write this like how you could understand it. You say 1 over 0.018 is equal to 24,000 over X. Solve for X. So therefore, X will be equal to 0.018 times 24,000. So if you multiply this, we say 0.018 times 24,000 will be equal to 432 cubic centimeters. So therefore 0.01 moles of carbon dioxide will occupy 432 cubic centimeters of space. And that was for 3 maps. Okay? Okay, it says from the graph, the total volume of gas produced is 360 cubic centimeters. So calculate the difference in volume between the answer obtained in D and the total volume produced. Now remember, theoretically, we don't consider impurities. We don't consider gases being lost, like poorly secured instruments such as a bong. So this suggests a possible reason for this difference, and that will be probably due to impurities. Suggests a possible reason for the difference, and that's probably due to impurities or to gas being lost due to poor connections made. So maybe you didn't grease the bong when you put it in, and gas was just lost through there, or maybe gas was lost through the syringe. All right. So let's work out the difference. So it'll be 432 cubic centimeters minus 360 cubic centimeters. And that will give us 72. That's the difference right there. 72 cubic centimeters, right? And the reason again will be due to reasons. Let me write reasons for this discrepancy may be due to impurities in the calcium carbonate or to poorly secured bond. State 3 factors that affect the rate of reaction between dilute nitric acid and calcium carbonate. So we have surface area, and there are a lot of things. Let me see here. Concentration, temperature, pressure. Yeah, so all of those things can work. So let's go with concentration. So if you had a more concentrated acid, you would have a faster reaction. Okay. Pressure is another one. Right? So all of that. Surface area. Temperature could increase the reaction as well. So all of those. Alright. And there, I guess I have the answers right there for you. So I'm just working it out so you can see this is the only question I'm going to work out because it had so much math with it. So hope you appreciate it. Okay, so it says, if marble chips or large granules of calcium carbonate were used instead of powdered calcium carbonate, sketch a graph of what this reaction would be on figure 2 on page 5. So it will pretty much look like this. The curve would shift to the right, but the same amount of carbon dioxide will be produced. Okay? And you had to label it sketch B. I think this was sketch A, graph A. Yeah. So you have to do what it says to do. So this one, they said to label it graph A. And let me make sure that it said label it graph A. And then the next one said to label this sketch graph B. Oh, so we had to label it graph B. So not sketch B. So we can label it graph B. Okay? Yay. So let me see. And then we have one more question. It says, complete the table below by identifying one similarity and one difference between graph A and B and suggesting one reason for each. So the similarity is the shape of the curve is the same. So the reason is the same amount of calcium carbonate used whether large granules are powdered, hence same amount of carbon dioxide will be produced over time. Now the difference is the position of the curve. Now the nature of the calcium carbonate is different. Powdered calcium carbonate provides increased surface area for the nitric acid to act with. So large granules of calcium carbonate means less surface area and hence slower reaction. And that'll be your 25 points. Okay? 25 points right there. Alright, so here we are on question 2. It says, Quasi went to the kitchen to collect his morning snack during his study break and saw some strips of green pepper in a container of water. He did not think anything of it, but when he returned to the kitchen later, he observed that all the strips were swollen. Ah, this must be osmosis, he thought. So, the first question says, define the term osmosis. Alright, let's go. So osmosis is the movement of water molecules from an area where there is a high concentration of water molecules to an area where there is a low concentration of water molecules across a differentially permeable membrane. Okay. Then it says, explain how osmosis in the paper supports the particulate theory of matter. Okay, so according to the particulate theory of matter, all matter is composed of particles and they are constantly moving about. This movement is due to the amount of energy they have and their relationship to other particles. The need for particles to equilibrate when two different concentrations come into contact with each other is the reason why osmosis occurs. Now, the green pepper was a solid that was placed into a liquid. State how the arrangement of particles in a liquid differs from that in a solid and a gas. Well, particles in a liquid are able to glide past each other, while particles in a solid are packed tightly together. On the other hand, particles in a gas are very far apart. Now, 4. Diffusion is another process that supports the particulate theory of matter. State one example of such a process. The spread of perfume molecules from the perfume bottle in the bedroom to the living room area in a house. You could also have food being cooked in the kitchen and it's spreading from the kitchen to all areas of the house. You can even speak about fats. I mean, if you're fat in one part of the room and it's spread out, everybody gonna know. So you could do things like that. Okay, so B. Alright, so it says element chlorine has an atomic number of 17 and it has two main isotopes with mass numbers 35 and 37 respectively. Define the terms atomic number and mass number. Okay. Now the atomic number refers to the number of protons present within the nucleus of the element. Mass number, however, refers to the sum of neutrons and protons within the nucleus. Then it says, show by calculation that chlorine 35 and chlorine 37 are isotopes. So, if chlorine 35 and chlorine 37 are isotopes, they're supposed to have the same amount of protons, and the neutron count should be different. So, again, isotopes are elements which have the same atomic number, but different amounts of neutrons. So, the atomic number indicates the amount of protons in the nucleus of the atom. So chlorine 35 has 17 protons but 18 neutrons. So to find the number of neutrons, you subtract the number of protons from the mass number, because the mass number is the sum of the number of protons and the neutrons, right? While chlorine 37 has 17 protons So therefore, if you subtract 17 from 37, you end up with 20 neutrons. Okay? Alright, now a student, while investigating the reactions of chlorine, bubbles chlorine gas into an aqueous solution of potassium iodide and deduces that the potassium iodide was oxidized because a color change occurred. And that should happen because chlorine is higher than iodine in the periodic table in the group. So, the higher up you are in the group of the halogens, you're going to displace whatever is below you, right? And it goes fluorine, chlorine, bromine, iodine. It says now, write a balanced chemical ionic equation with state symbols for the reaction that is responsible for the color change. So here I have chlorine gas, and then we have potassium iodide. So they said it was a solution, so I put aqueous, and I wrote a balanced equation. So because the chlorine would displace the iodide, we end up with potassium chloride and iodine, okay, which is a liquid. Now get rid of the spectator ions. So basically you have to know what your ions are. Anything that's a gas or molecular, such as chlorine gas, you don't break apart, but anything that's aqueous, you break apart. So your ions that's in this is potassium ions and iodide ions, okay? And this is all on the left hand side. Over here now, you have another molecule, which is iodine, and we don't break that apart either, but we break apart the aqueous solution here, the ions in the aqueous solution here, and we see that potassium is separate from the chloride ions, okay? Then what you do to get the ionic equation, you look at side A, which is on the left, and side B, which is on the right, and you look for repeater ions. So from this we see that the potassium ion repeats itself. We get rid of that, and we have our ionic equation. Voila! We have this chlorine gas reacting with 2 moles of iodide ions to give you 2 moles of chloride ions plus iodine liquid. Okay, that's 15 points right there. Hope you got these answers. Alright, so we're on question 3. It says compound A is a straight chain hydrocarbon with the molecular formula C5H12. Say 1 natural source and 2 uses of compound A. Source, fossil fuels. Uses, as a binary fluid in geothermal power stations and as a blowing agent used to create foam known as polystyrene to make insulation materials for refrigeration. And the tallest is a straight chain hydrocarbon, so we just draw the straight chain. So we draw our 5 carbons all attached and our hydrogens attached. So make sure each carbon has 4 bonds. When you add the hydrogens, it comes up to 12. Okay, that would be 2 points. Now, it says thermal and catalytic cracking are very useful processes in the petrochemical industry. It says 1, define the term catalytic cracking. Now, catalytic cracking is the breaking up of long chain hydrocarbons into shorter chain hydrocarbons via the use of a catalyst and temperatures of above 500 degrees Celsius and fairly low pressures. In this process, alkenes and alkanes are produced. Now state the importance of catalytic cracking in petroleum refineries. Now catalytic cracking produces very reactive alkenes, which are used in petrochemical industry to make many other useful organic compounds. Fractional distillation, on the other hand, does not produce alkenes. Then it says ethene undergoes a halogenation reaction to form 1,2-dichromoethane. Draw the fully displayed structure of 1,2-dichloroethane. So 1,2 means that the chlorine atoms are on each of the carbons. And at the back here we see ethane. We're dealing with ethane, has 2 carbons, so you draw those 2 out. And there's only 2 carbons, so it's 1, 2, so you put the chlorine atoms there and you fill out the rest with hydrogen. That's 2 points. Then here it says dichloromethane can be obtained from methane. The reaction takes place in 2 steps. Write balanced equations to show each step in the formation of dichloromethane. So we start out with methane, and we have chlorine gas, and then one of the hydrogens are substituted with a chlorine atom, and then we have hydrogen chloride, and then the trend keeps going on, and we end up with what we need to end up with. State whether the halogenation of methane is an addition or substitution reaction. Once you're dealing with alkanes, it's going to be substitution, because it's substituting a hydrogen for halogen. Addition reactions occur when you're dealing with alkenes. Alright, so we're going to start question 4 in a bit. Okay, now we're on question 4. It says the position of an unknown element Q is shown in the periodic table in figure 3. And it says state 2 factors that are used to arrange the elements in the periodic table. Well, for one, the number of valence electrons place elements in groups, and the number of energy levels place elements in rows or periods. Now, based on the position of element Q in the periodic table, state whether it would react more vigorously or less vigorously than with water than magnesium. As you go down group 2, things get wild. So it would definitely react more vigorously. Okay, now state whether the solution formed from the reaction of Q with water will be acidic or basic. Give a reason or give a range on the pH scale in which the solution will occur. And I mean, group 2 metals are called alkaline earth metals. So they'll be basic. pH range will be 8 to 14, because that's the basic path of the pH pH range or scale, 8 to 14. Now, based on the position of element Q, write the formula for its carbonate formula. So the formula would be QCO3, because Q is in group 2, which should mean that it has an oxidation state of 2+, and the carbonate anion has an oxidation state of 2-, which would cancel out each other, giving you QCO3. Now, sodium reacts with chlorine to form sodium chloride, a solid compound with a melting point of 801 degrees Celsius, which conducts electricity in solution or when molten. Deduce the type of bonding present in sodium chloride, and it's ionic because it's occurring between a nonmetal and a metal. So that's ionic, which is the nonmetal is the chlorine and the sodium is the metal. Now, it says here, state the appearance that sodium chloride is expected to have, and let me see here. It says sodium reacts with chlorine to form sodium chloride, a solid compound that with a melting point. Now, in its solid state, it will be white and crystalline. Okay. Now, carbon is a non-metal element that is in group 4 and exists in 2 forms, diamond and graphite. Which of these forms of carbon conducts electricity? And that'll be graphite, because graphite, it contains only carbon atoms, which they form rings. Okay, so they form rings, so 6 of them bond together to form a hexagonal ring. And because of that, the carbons only bond 3 times, and because of that, the 4 electrons that are available for bonding, out of them only 3 actually do the bonding, so they have an extra electron that's not bonding. And because of this extra electron, you would have this flow of electrons existing inside of graphite itself. Okay, so let me see if I could draw it here, just to give you a little visual. And so this is how it bond. Okay, and so because like you will see here again, bonding here, and if you look here, you see 1, 2, 3. So it's only 3 bonds, and you have that extra electron here by all of them. Okay, to give that flow of electrons. Because remember, a conductor contains mobile electrons. It says, show by using diagrams the difference in structure between diamond and graphite, which accounts for the difference in conductivity. Use solid lines to show strong bonds and dotted lines to show weak bonds. So here we have diamond. Diamond is a tetrahedral structure, and you have that central carbon, and you have the bonds here between other carbons. All the electrons are involved in bonding, so there are no free electrons to allow electricity to flow through diamond. With graphite now, you have this hexagonal structure which I showed you earlier, and then you have these weak van der Waals bonds between them. Now the hexagonal shapes that are form plates which are able to glide past each other. That's why graphite can be used as a lubricant or can be used for writing. Okay, and that's it for question 4. Now for question 5, it says a fully displayed structure of compound B, C4H8, is shown in figure 4. It says deduce the homologous series to which compound B belongs. Once you see a double bond, it's an alkene. And it says write the name of compound B. A double bond, 4 carbons, that's butene. Now compound B exhibits structural isomerism. Determine the term structural isomerism. Well, these are isomers that have the same molecular formula, but the atoms are arranged in a different order. Then we go draw a fully displayed structure of any structural isomer of compound B and name it. So I moved the double bond and I named it 2-butene, or it could be 2-butene. Okay, so I moved it. Okay, so that's that for that one. And then we have here ethene and propene are typical monomers which are used as starting materials for making polymers. In forming polymers, ethene and propene undergo addition polymerization. So it gave you an answer here because when you move on in the question, it's going to ask you something. So note well that ethene and propene, which are alkenes, undergo addition polymerization. It gives you the answer. This says define the term polymer. That's many monomers bonded together. Then it says define what is meant by addition polymerization. This is the type of polymerization that is achieved via the bonding of alkenes. So that's what addition polymerization is. It's the type of polymerization that is achieved via the bonding of alkenes. Now it says state one use of each of the following polymers. Polyvinyl chloride, which is known as PVC, is used to make plastic pipes, whereas Teflon is applied as a protective non-stick surface in pots and pans. Used to make what? No? I guess that was not. That was probably had a different idea somewhere. Alright. Oh, I think I was going to say used to make no-stick pans or something like that. So, yeah. But that's the mark you will get if you put that there. Alright, so there are several different types of polymers. So figure 5 and figure 6 below show the partial structure of a polymer. Deduce the type of polymer shown and the type of polymerization reaction that took place in each case. And so to determine this one, you just look for this. So once you see once you see OCNH, it's a type of polymer which is known as polyamide. And the type of polymerization is condensation. In these type of bonds, you will lose either water or maybe HCl, things like that. But water was lost here. Now, repeating units like these that you see here usually deals with alkenes. So the type of polymer is a polyalkene, because the unit, if you draw it out, would be CH2, as you can see here, and then the CH and the CH3. So if you break them apart, you will see that this is the same thing here and this is the same thing, and the unit just repeats itself. So it's a polyalkene, and the type of polymerization is addition polymerization. And that's it for question 5. Now moving to question 6. Question 6 looks like it was dealing with environmental chemistry, and it says here, chlorine bleach can be used to prepare emergency drinking water supplies in times of natural disasters when pipe-borne water is unavailable. It is made by mixing chlorine and sodium hydroxide, such as caustic soda, in a kind of reversal of the chlor-alkali process. So question 1A, or A1 says, state one physical property and one chemical property of chlorine. Now, one physical property of chlorine is that it is a yellow-green gas. Now, physical properties are observed and measured without changing chemical identity of sample, example, color, length, volume, or opacity. Whereas chemical properties are observed and measured as sample changes, like chemical identity, example, acidity, reactivity, flammability, or toxicity. So from that, one chemical property of chlorine is that it has an electronegativity of 3.0 according to the Polymer scale. Now describe a simple laboratory test that can be used to determine the presence of chlorine gas. Where chlorine gas turns moist red litmus paper blue, then bleaches it. Now state 2 uses of chlorine gas other than that for purifying drinking water, as to make antiseptics, example Dettol, and to make insecticides, for example DDT. Now, CFCs are organic compounds used in refrigerants and propellants, in spray cans for deodorants, paints, and insect repellents, and are known to be harmful to the environment. State the meaning of the term CFCs. Now, chlorofluorocarbons is a substance that contains only carbon, hydrogen, chlorine, and fluorine. Give a named example of a CFC and state its formula. Freon is an example, and the name of freon is dichloro-difluoromethane. Then it says give the name and the formula of a molecule with which CFCs react within the environment, and that is ozone. Okay, ozone, O3. That is what ozone is. This O3. Describe the process by which the use of CFCs results in a harmful effect on the environment. So CFCs destroy the Earth's protective ozone layer. This is not good since the ozone layer protects the Earth from harmful ultraviolet rays which comes from the sun. Owing to this, the climate on Earth will get warmer. This can cause the melting of the frozen polar ice caps, which is detrimental to our environment since melting polar ice caps can raise the level of the seawater, which could cause severe flooding. Now, polar ice caps also reflect light and heat away from Earth's atmosphere, which helps to keep Earth from heating up. People can also suffer from more instances of skin cancer, cataracts, and depressed immune systems if the ozone layer is destroyed. And there, my dear students, that's the end of the test. I hope that you were able to answer all these questions. I think they were doable. You just need to read your text. Okay? I'll be posting more later on. Best wishes in your exams for 2022 June. Bye.